We are biomedical engineering master's students at Johns Hopkins University working on a global health innovation project in collaboration with Medtronic. Our goal is to increase pacemaker adoption in underserved areas in India. A pacemaker is a small device that is implanted subcutaneously in the chest in order to treat abnormal rhythms of the heart. A pacemaker is comprised of a pulse generator that sends electrical impulses to the heart wall via one or more leads which sit inside the atria and the ventricles. Pacemakers in India are implanted in a cath lab at tertiary care facilities by interventional cardiologists. Hospitals with cath labs are primarily concentrated in the metro cities. Since 70% of India's population live in the rural areas, many people have to travel to the nearest city from the peripheries in order to receive a pacemaker. Traveling up to 9 hours to get to a hospital is not ideal for a patient who is in need of emergency care. And once the patient reaches the hospital, they must wait for up to a week before receiving their pacemaker because tertiary care hospitals in India are often understaffed and over capacity. Therefore, in India, temporary transvenous pacing is used as a bridge therapy to stabilize the patient until an interventional cardiologist is available to implant a permanent pacemaker. We hypothesize that if pacing is introduced earlier on in the patient care pathway by increasing the access of temporary pacing to smaller hospitals in the more rural areas, more patients will receive permanent pacemakers in the end. The function of a temporary pacemaker is similar to a permanent pacemaker, but the pulse generator sits external to the body. The first step to this procedure is to gain venous access to the jugular vein. The proximal, positive lead is then attached to the positive terminal of the pulse generator, and the distal, negative lead is attached to the V1 lead on the EKG machine. The lead tip is able to sense the intrinsic electrical activity of anything that touches as the lead is advanced into the heart. By interpreting the electrical tracing displays on the V1 channel of the EKG machine, it is possible to determine the location of the lead tip. The objective is to position the lead tip inside the right ventricular apex. As shown in the image, the lead is guided from the jugular vein through the superior vena cava into the right atrium, past the tricuspid valve, and into the right ventricle. It is important to pace the lead tip deep into the right ventricular apex so that it does not dislodge. In the United States, this procedure is routinely performed by emergency or critical care doctors blind at the bedside. However, in India, this procedure is typically performed under fluoroscopic guidance by a cardiologist or cardiology resident. We hope to increase access to temporary pacing by training emergency and critical care doctors to implant temporary pacemaker leads blind at bedside without the need for imaging capabilities. Blind lead navigation can be challenging. Therefore, our team has designed an EKG-guided lead navigation simulator to increase the confidence of these physicians in implanting temporary pacemakers.